Hey everyone, today we are diving into equivalent fractions. Again, as always, we're going to be thinking about that process through 3 steps. We're going to model, we're going to make a replica, and then we're going to cut, and then we'll count. I'll explain all that. Makes sense. We might even change some of this language to stick in our heads on these steps now that I think about it. I'm gonna call this copy. So model, copy, cut, count. I feel like that kind of sticks in our brains better. So let's change the rules right here. Funny how I just thought of that. Anyway, remember equivalent. This is definitely one of my favorite words. I've talked about this word a lot. Mathematically, I just love what it means and how it helps with so many things we do. The concept again of equivalent means it's got the same value. It's worth the same amount, right? Same value, but it looks different. And we can see that in all aspects of math. Another example of equivalent could be something like this, like 35 plus 10. Well, if over here I wrote 45, that's actually equivalent. So it's not just a number sentence, but it's the reality of then again, this value right here is 45. And so is this value here, it's 45, but they look different. So that's even a sense of equivalent. We've also looked at that recently with fractions, with this idea that if I have 12 out of 12, well, that is actually equivalent to 1, right? Again, same value, but it looks different. And why is that? Because, well, 12 divided by 12 is 1, right? So again, this concept of equivalent means I have something with the exact same value, but it looks completely different. So we're going to be looking at fractions today and how we can create equivalent fractions, how we can create fractions that look different, but actually have the exact same amounts. And again, we're going to do that with this new system that I just thought of. We're going to model, we're going to copy, we're going to cut, we're going to count. So let's dive in. Let's play with it. Let's do the job. So let's take our first fraction. It's 1/3, right? Let's just start there. Okay. So again, right, we are going to model. We are going to copy, cut, and then count. Boy, that does really flow off the tongue a lot better. So let's do that. So step 1, model. I have 1/3 here, or 1 out of 3, or 1 divided by 3, or however I want to read this fraction. So the first thing I'm going to do is I am going to model this fraction. So the denominator tells me I have 3 equal pieces. The numerator tells me one of those is the one that's shaded in. So there's my model. Makes sense. I just modeled 1 out of 3, 1/3. And now let's move on to the next step. It says to copy. And so that's actually what I'm going to do. I'm literally going to copy this same model. And I'm going to try to do it as precise as possible. So there's my copy. Okay, so model the fraction we have, and then I made a copy of that exact fraction. And now this next step, it says over here is we're going to cut. What that means is I'm actually going to cut this second fraction model in a different way where I still have equal pieces. So for me, I'm just going to go right down here, and you can see I've made new sections, but they're all still equal. Now that takes me to the last step. I'm going to count. Well, let's start with counting all my pieces first. I have 1, 2, 3, 4, 5, and 6. So that's my denominator. And if I count how many are shaded, I have 1, 2, and that's 2, 6. And what then this model tells me is that 1 out of 3 is equivalent to 2 out of 6. They are exactly the same. They may look different, but they're the same. So if someone said to you, hey, do you want 1/3 of $1 million or 2/6 of $1 million? You can just laugh at them and go, ha, ha, ha. Those are the same values. I'll take either or something. Because obviously there's people walking down the street offering you fractions of millions of dollars, obviously. Okay, so that's one example. As always, we're going to keep practicing our examples so they make sense. So our steps: model, copy, cut, and then count. All right, so let's take another fraction. Let's do the fourths. Right, what did I do? Thirds last time? Yeah, cool. So let's just do a different denominator. Okay, so it's 2/4. So let's play that game. Step 1, model. So I'm gonna model the fraction I have. I'm gonna make a nice little rectangle. The denominator says 4, so I have to go 1 and then the middle. So there's 1, 2, 3, 4 pieces. And then the numerator says that 2 of them are colored in. So here and here. Okay, so now let's make a copy. We're going to copy this exact one. So I'm going to make sure that I do my very best to try to copy it the best I can. Ooh, that's not the straightest. There we go. And again, part of the copy is I'm going to color in the right pieces like I did before, the exact same. Notice that, right? I didn't like shade up here. That wouldn't really help us. It's a copy. Okay, so here's 2 out of 4, and I just made another copy. But now we're gonna cut. So I'm gonna take this second model I just made, I'm gonna cut it. So maybe this time, I'll just cut everything in half like this. And again, they're still equal pieces, but this time, as we get to the count, you can see I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And 1, 2, 3, and 4 are shaded, meaning now that 2, or excuse me, that's not a 2, that's a 4. 4 out of 8, or 4/8, is equivalent to 2 out of 4, or 2/4. They're equivalent. They are the same. Right? So the crazy man walking down the street with a briefcase full of $1 million says, ha ha ha, I found you. I don't know why that was his accent. I don't even know what accent that is. The money man. Anyway, what do you want? 4/8 of $1 million or 2/4 of $1 million? This is a ridiculous example, but the reality is they're the same. So you can once again look at the crazy man with the briefcase of money and say, ha, I'll take either because I get the same amount. And I don't even know why this is so dramatic, that there's just a man walking down the street with a briefcase full of money asking you what fraction you want. Wow. Okay, sorry. Let's move on. Let's just do another one. Let's keep practicing. So again, model, copy, cut, count. Model, copy, model, copy, cut, count. Remember earlier when I said that just float off your tongue? Apparently it doesn't. All right, so again, our steps, we are going to model. We are going to copy. We are going to cut. We are going to count. So again, I don't know. Let's do, what did we do? Fourths, we did thirds. Oh, thirds, fourths. Oh, let's just do half, whatever. Let's do that. Let's do 1/2, right? Because this one's actually kind of cool because we can think about other ways this works. Anyway, so step 1, model. So I'm going to take and I'm going to draw the perfect, most amazing model of 1/2 or 1 out of 2. Right? So the denominator says there's 2 pieces. The numerator says one of those gets shaded. That is 1/2. We are going to copy this. So I want to copy it to look exactly the same. So I am doing that. Sorry, I kind of zoned out. Let's do that there. Okay, so there's the copy. Now we're going to cut. So we're going to cut this one in a different way. So watch, I'm going to get crazy. Check this out. Ooh. So I'm going to go right down the middle. But then, you know what? I'm also going to cut it this way and this way. And if you can see, I've actually made, we'll put it up here, I've made still equal pieces. And that's what's super important about the cut, right? You got to make sure that your pieces are equal. Otherwise, it's not going to work. So you put it into equal pieces, and now let's just count. First, we're going to count how many pieces we've made. 1, 2, 3, 4, 5, 6, 7, and 8. So that's my denominator. And then we look at how many are shaded. Well, 1, 2, 3, 4. And again, that means that 1 out of 2 or 1/2 is equivalent to 4/8. They're the exact same thing. They carry the same value. They just look different. So now, I don't know, a different scenario. Someone offers 1/2 of their candy bar or 4/8 of your candy bar, right? Then you now know that it's the same amount. Or if you want to get tricky, you can even just say to someone, oh, nah, I don't want half your candy bar, but could I have 4/8? Well, actually, you end up with half anyway, right? So maybe you can use this to help you get more candy bars. Boy, math. So far, we've learned today that math will help you get millions of dollars from a man walking down the street with a briefcase, or it will just help you get candy bars. Yeah, I don't know. I had to pause and really think about that. That's not what we're learning. We're learning equivalent fractions. So today, I hope that made some sense, right? Equivalent fractions, fractions that look differently, but they have the same value. And again, we did that today by going ahead and making a model of our fraction. We then copied that model and then cut that model. And then we just counted what we had, and that helped us do it. So I hope that works out for you. I hope that makes sense. Again, as always, feel free to ask the questions. That's what we're here to do. That is a math norm. You ask questions till things make sense. You explore things to make sense, and you practice and you practice and you practice till they make sense. That's what we can all ask for. So as always, thank you for your time. We appreciate you, and we will see you later.